Okay. అలాగే ఒకసారి 1 minute మెన్షన్ ఆపమా నేను 4 ఇన్స్టాగ్రామ్ ఇచ్చాను మీరు ఇప్పుడు
ఆ లింక్ కనెక్ట్ చేసుకోవచ్చు
రావడం లేదు అక్కడ రావడం లేదు ఎక్కడ
మేడం గారు
శర్మ ఉంటుంది జూమ్ చూడండి Good morning, dear students, for the GATE class 8 on engineering mechanics. Today we are going to discuss on dynamics of particle or a mass or a rigid body. Here, once again, thanks to JNTU and Kakinada, Anantapur and Yogi Vemana University and Ambedkar University conducting these GATE classes. And today we are going to concentrate on D'Alembert's principle of a particle or a point mass or a rigid body. Again, little bit brush up your knowledge with what we have done yesterday. Here, the learning outcomes, what we are going to get, you have to represent, express dynamics of a particle, rigid body, and differentiate between the kinematics and kinetics. Recognize and apply the concept of these principles like Newton's laws, moment impulse, work energy, and D'Alembert. These all are yield the same result. But only thing is depend upon the input data. We have to find out the output, whether we have to use a Newton's law or moment impulse or work energy or a D'Alembert's principle. Okay. Derive an expression for today. We will concentrate on this. You are going to get for all types of motions like translation. In a translation, again rectilinear translation, curvilinear translation, rotation, and plane motion. The concepts must be really understood by every student. Once you clear with the concept for a particle and rigid body, you can apply for any physical system. It can be a mechanical or a civil or electrical, electronics, any system you can consider. Then update your knowledge as per the need. So these are the learning outcomes what you are going to get from today class. Now the kinetics is yesterday we already, by this time you should be very familiar. It is relation between the force, mass of a body and motion of a body. That is F is equal to ma, or rate of change of momentum. The dynamic principle, D'Alembert's principle, is also a part of that. The motion caused by given forces are to determine the force required to produce a given motion. The analysis of forces which cause the motion, type of causing the motion. My password. Which is the analysis type of force causing the motion. Dynamics is the study of force as it works on a rigid body in a motion. For any type of now this is yesterday also we discussed. Today we are going to discuss in kinetics by again 3 by applying a D'Alembert's principle. See again this part with D'Alembert's. That means this is the domain what we are considering today. Mechanics, in the dynamics, in dynamics again kinetics, in kinetics again D'Alembert's principle. Okay. So this is how the class today, 2 hours class we will plan. So this is kinematics part, linear velocities and angular velocities regarding translation degree of freedom and rotational degree of freedom. A scalar representation and vector representation, velocities and acceleration. Because in a vector we will consider cross product, omega cross r relative velocity. See, that's how we will consider the kinematic analysis. Now kinetics. The kinetics, only translation one equation, only rotation one equation, or a combination of both. Okay. Whereas in a rotation part, moment of inertia you can determine by mk square or mr square or I plus s square m. Okay. This can be a simple harmonic motion or Newton's laws you can solve, or energy methods, or energy Rayleigh energy method, or D'Alembert's principle. Today we will concentrate this part, the D'Alembert's principle. Okay, we will see how this problem can be solved by using this particular principle. See, these again, what are the equations? This also we discussed yesterday. F is equal to ma, or torque is equal to I alpha, momentum is equal to mb, I omega, force into displacement, torque into displacement, kinetic energy half mv square, half I omega square. 1 minute, sir. Sir, good morning, sir. Commission level.
Sir, good morning, sir.
అంతే సౌండ్ ఇంకా పెంచాను
అన్మ్యూట్ చేయండి సార్.
పెంచాను సౌండ్ అంత ఇంతేనా ఏమి పెంచినావు
తీసేయండి సార్, చూడండి సార్.
Yes,
these supercomputers and mainframes. And thereafter, as the computing capacity started improving, your desktop today is as well as a supercomputer of yesterday as maybe 12 years back. All the capacity and the technological advancements made this CFD very much possible to be accurate and possible. Let me tell you,
రిజిస్టర్ కనెక్ట్ స్ట్రీమ్ లో నెంబర్
CFD approach of solving that flow issues of
శ్రీ న్యూటన్స్ సెకండ్ లా మొమెంటం వర్క్ ఎనర్జీ మంద మ్యూట్ పెట్టి సెల్ లో ఇదేం మార్చలేదు పవర్. So now these are the moment of inertias what I discussed just now. This part of moment of inertia can be for different types of solids like shell, cylinder, or a sphere, or any thin rod. We can consider the moment of inertia can be considered. Now the dynamics can be considered 3 laws of motion. Right set and so. A particle original at rest are moving in a straight line with constant velocity. This we already discussed yesterday. It is a particle originally at rest are moving at a straight line with constant velocity tends to remain in the state provided the particle is not subjected to any unbalanced force. If you determine the resultant force, if it is at rest v is equal to 0, if it is a constant velocity, that is called the static principle. Whereas the dynamic is the rate of change of momentum. Rate of change of momentum. Force is equal to mass into acceleration. And here the acceleration is proportional to the force that can be considered, or rate of change of momentum, or you can convert moment impulse work energy also. The same equation F is equal to ma, you can convert. Whereas third law, very well. You are playing with your friends, brothers and sisters. For every action, always there is an equal and opposite reaction. This is what we are using in mechanics problems and other things. So that's what these are the fundamentals. Now let us today will concentrate the general dynamic equation of motion by using D'Alembert's principle. Okay. బయట నుంచి నాకు ఒకవేళ వాళ్ళకి అడిగితే నాకు ఇవ్వండి వెంటనే చూడండి ఆడియో సెట్టింగ్ పెట్టేసి సో నౌ ద D'Alembert's principle general dynamic equation of motion using D'Alembert's now let us consider Newton's law and D'Alembert's. What is the difference? The rate of change of momentum is directly proportional to the the force. The resultant force acting on direction of motion is equal to the product of mass into acceleration. Product of mass into acceleration. See, mathematically it can be represented as F is equal to ma. So now you can see that by D'Alembert's principle, this one, D'Alembert's principle can be represented as per Newton's second law, force is equal to ma. Now let us see this F is equal to ma can be, this is force and this is the rate of change of momentum. M is equal to dv by dt. Acceleration is dv by dt. This m is constant. If you take dt outside, it is rate of change of momentum. See, the resultant force, due to these forces, there is a resultant force. That resultant force acting on a body which is on dynamic nature. Now we want to keep in static this resultant force or inertia force. This is nothing but the inertia force in dynamics. This resultant force is equal to a mass into acceleration. That is an inertia force. If that force is applied in the opposite direction, like this, see, then what we can consider as F is equal to ma. Negative sign. Opposite means negative sign. F plus inertia force. It together is 0. But what is the advantage is by using D'Alembert's principle, you can convert a dynamic. This is actually the problem is dynamics. You can convert into statics. And that means in equilibrium by adding inertia force to the system. Okay, in the opposite direction. See, that is what is the purpose of D'Alembert. Advantage is to convert dynamic problem into static problem. You can keep in equilibrium, even if it is in a motion, but I am applying the same amount of the resultant force proportional to the inertia force in the opposite direction. See, that principle is called the D'Alembert. It is simply a modification of Newton's second law. Whether you can use a momentum energy or the momentum impulse or work energy, these principles we can modify. Now let us see here. With this as a resultant force and this is an acceleration, the body is moving. Okay. Now I am applying inertia force mass into acceleration in the opposite direction. What is understand by equilibrium? Where when you are applying a dynamic D'Alembert's principle, this equilibrium we are calling here the dynamic equilibrium. Dynamic equilibrium. In the dynamic equilibrium condition, we will consider The equation we called as the dynamic equilibrium. Okay. A body moves acceleration with this as an acceleration, the body is moving. One minute.
Sir.
Hello? Hello? Sir, good morning, sir. Hello? Can I? Is it okay, sir?
Ramjee, sir.
Is it okay, sir?
Okay, sir. Sir, 1 minute, sir. 1 minute, sir. So now I
Students, 1 minute.
to read out the free profile of the Ramjee, sir.
Okay, we will save the time. Sir, we will save the time. I will speak 1 minute.
No problem, sir. Just let us allow me to read out the free profile, sir.
No.
Just now.
Because I will get just 1 minute, I will give my
Okay, sir. Okay, sir. Please, sir. Please, sir. Thank you.
respected the chairman of APSIS, the Professor Ramjee garu, and the entire team of Vigyan Bharati, and Professor Avadani garu, the director of AAA. Thank you very much for hosting this particular event in collaboration with AAA and Vigyan Bharati and Dr. B.R. Ambedkar University. Thank you very much for giving this wonderful opportunity. My dear students, today the world is moving with the digital technology. That is in our subject point of the computational fluid dynamics. Just now, Ramjee mentioned computational mechanics. In the computational mechanics, we are mainly concentrating on any problem, like even macro level, micro level, nano level, tera level, you can try to solve. The scale. Earlier, this advantage is not there. A lot of job opportunities now coming. This particular subject is useful in jobs in core sector with computational technology, with the computational fluid dynamics. Any complicated system, any type of loading, any type of boundary conditions, for any system, even a physical system or a mechanical system, or solids, liquids, separately or together, like multi-physics problem, can be solved. Unmute, Krishna. Krishna. Krishna, you know that you can unmute. Sir, okay, na? Okay, sir? Sir, is it okay? Audible, okay. Okay, sir. Welcome to. Now I can start. Hello? 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 Sir, only 1 minute present told me. Once again, thank you very much for Vigyan Bharati and Professor Avadani garu, and Dr. B.R. Ambedkar University, Srikakulam, for giving this opportunity. And also thanks to Ramjee garu, acting as a chief guest and given wonderful inaugural address. The importance of CFD, but he is a man. There is a lot of work related to CFD, computational fluid dynamics in mechanical engineering. We guided a number of PhDs and MTechs. Thanks for Professor Ramjee as the chief guest for this function. See, nowadays, any mechanical system consists of combination of loading like complex loading, complex structure, complex boundary conditions. Any type of problem can be real life system can be simulated by using these tools like computational fluid dynamics. Here basically the governing equations what we are using is conservation of mass, conservation of momentum, conservation of energy, like Navier-Stokes equation, Bernoulli's equation, etc. When the problem things cannot be solved by using analytical method. We will approach the numerical method. This is one of the numerical approach where we can solve any problem like solids separately, liquids separately. Generally, we will consider in our mechanical engineering or any subject. But this is a case where we can study the multi-physics problems. That means where the solid and the liquid, like a ship moving on water, aircraft moving in air, locomotive moving on a track, these are multi-physics problems. A real life system or even electronic computer motherboard is having a solid and liquid cooling. Air may be passing, sometimes coolants may be passing. So any such problem can be solved by using this particular CFD. And that's why this is not only the mechanical, even electrical, electronics, mechanical, chemical, all long types of students can solve their problems. That much importance. If anybody has expertise in this particular with the software to solve any problem, we have a lot of job opportunities. Nowadays, because of Corona, we can do work from home. This is a tool where if you have got expertise, both theoretical part and computational tools. Only computational tools you are familiar. If you don't have the fundamentals, then you don't get any success. So that's why, what are the governing equations, at what conditions we are going to use those equations, depend upon the type of problem, what input to be given, what output, depend upon the output, what will be modified, processing, post-processing stage. We should be very familiar with. Thank you very much. Once again, Vijnana Bharati. And Professor Ramjee and again Ambedkar University family. And congratulating this faculty development program. And I also thanking Ramjee Reddy Garu for already given a wonderful inaugural address. Thank you very much for this wonderful opportunity. Okay, sir.
Thank you for your time.
Okay.
Thank you, sir. Thank you for the wonderful speech, sir. And now I'm requesting Kishore to propose a vote of thanks for this inaugural session.
మనం ఈసీ కైండ్లీ చేసింది నేను చెప్తాను మధ్యాహ్నం 12 గంటలకు.
Sorry, dear students. Here discard అవుతుంది. There is a small important so now we will see the concept of dynamic equilibrium. Dynamic. So now we will concentrate the part of the resultant force, which is acting on the force of the total. Two will be equal and opposite. The system is in equilibrium. Now this equilibrium is called the dynamic equilibrium. Okay. Earlier is a static equilibrium. When you are solving a problem, that is a static equilibrium. And when you are considering, it is a dynamic equilibrium. Okay. When there is a D'Alembert's principle, this equilibrium is called the dynamic equilibrium. Otherwise, we can solve the problem. See, now if we can see this one, this A and A is acceleration, this is the resultant force, and initial force is acting in the opposite direction. So that is how we will try to consider the problem. So now this is what the dynamic equilibrium equation, F plus Fy. F is plus Fy is equal to 0. That principle is called D'Alembert's principle. This can be applied for the body in translation, the body in rotation, the body in a plane motion, or any types of motion we can consider, whether it is a 2D or a 3D. So now let us consider next the same principle. The definition of D'Alembert's principle is, D'Alembert's principle states that the resultant of force or resultant torque acting on a body together with the reversed effective force or reversed initial torque will keep the body in equilibrium. Okay. So this is how generally we'll consider the equilibrium concept. That equilibrium, to differentiate under static condition, we'll consider this is the dynamic equilibrium, not a static equilibrium. Because of dynamic problem, we are considering as an equilibrium condition. Okay. See now, let us consider the same. The body is having the mass applied force, due to that any mass is moving or bullet is moving. Now I am applying initial force in the opposite direction. Actually, this is a force proportional to the acceleration moving in this direction. But that initial force, mass into acceleration, I am putting in the opposite direction. This is the acceleration direction, but I am putting in the opposite direction. That opposite direction, what we are putting is called this, like this, applying in the opposite direction. Okay. So this is what we will apply. Now let us see that this will be in equilibrium. See now, same schematic representation, force, inertia, mass, this F plus some of the forces. Fi may be negative, but some of the force is equal to 0. That is the resultant force plus inertia force. Okay. See, that is what we are calling as the concept of the mass into acceleration. We are considering as the DLM. But similarly, here if you can see, F plus summation of the forces. F means this is the summation, and this initial force is also, you can sum up with a plus or minus. And this force system, this is the force system where four forces are acting. We can represent the resultant force is equal to mass into acceleration. Now let us consider, this is the case where, which we can be considered the components along in this direction and components tangential direction. We can consider normal and tangent, along the plane and perpendicular plane. This is the normal direction and this is the tangential direction. Okay. So now what we have to do, this mg, this is the weight acting, this is a plane surface and this is the inclined surface. Okay. Now what we have to do, we can consider mg, m into g, acceleration due to gravity, the g along the plane. Let us assume this is the direction of acceleration. We have to apply initial force in the opposite direction. Initial force. So that is what is your F I, initial force. This Fi plus this component mg sin theta plus F, because this is opposite and these two are in the same direction. So that's why it is negative, plus F and plus Fi, initial force. Initial force is equal to 0. So this is how we will consider the equation mg sin theta plus minus F plus F is equal to 0. And similarly vertical in the because this is the initial m into a acceleration. This is the frictional force, and this is the component. Okay, so this is how we will consider the problem and try to solve the problem. So now D'Alembert's principle. This is an inclined plane, whereas here this is the inclined plane and the body moving along, sliding on an inclined surface. One minute. Suppose if you can consider here, this initial force is equal to the this initial force acting in the opposite direction. Now what we have to do is, we can component to initial force and this force we have to count. Now in a plane, inclined force, P, weight acting downwards, frictional force between the two, normal reaction. Actually this is the direction of acceleration. So that's why initial force must and should be opposite. You have to apply. Now resolve the forces. Sin theta component, P cos theta is horizontal component, P cos theta, P sin theta. So that's why as far as horizontal is concerned, there is no acceleration in that perpendicular direction. Only perpendicularly the acceleration is zero, only 1 degree of this is force. Now if we can equate both, and that is one equation, but horizontal equation is if I can apply Newton's law and D'Alembert's principle, as per Newton's law equation is P cos theta, because force and acceleration must and should be in same direction. P cos theta is equal to A and frictional force, because this is the motion, frictional force is in this direction. This is the direction. That's why reaction is equal to mass into acceleration. That is Newton's second law. If we want to write D'Alembert's principle, now this is the force we have to apply. Now the equation is this and this same direction, this is opposite, P cos theta. P cos theta is equal to 0. If you see the previous one and this one, you will have the same equation. If these two are positive, this is negative. How we are considering the positive and negative axis? And similarly, fx, fy, here P sin theta. If P is along the plane, it is 0. But P inclined to the plane, then that component also add. Earlier, what I said, weight is equal to N is when the P is acting along this axis. If P is inclined, it is having two components. One is vertical and another is horizontal. This is P sin theta. See, because of that, N plus P sin theta is equal to W. N plus P sin theta is equal to W. That is W, weight. If it is there in vertical acceleration, this component. Otherwise, it is 0. Okay. Actually, at this particular point, it is 0 only. No initial mass into acceleration. Only weight is equal to mg. N, P. Find out N. That N you can substitute here. Find out P. Okay. So this is how generally we will try to consider the simple problem by using the D'Alembert's principle. The same thing here. Same problem. I have the frictional value is little bit more here. Now we can find out what is the reactive force, whether it will reduce or it will enhance. These type of studies you can study. When the frictional force is 0.3, when the frictional force is 0.4, 0.5 or 0.1, 0.2, but this is you can study. As you go on increase, what is the limiting friction you can find out sometimes in dynamics also. Now if you can see instead of one block, there are two blocks. 15 Newton block, 25 Newton block. This is the force applied, 40 Newtons. Now if you can see the free body diagram, this is the tension in the string, T, this is the force 40 and 15 Newton weight acting downwards because frictional force is in this direction. And if you can find out, if you can see by applying D'Alembert's principle, T is acting in this direction. This is one and this is another acting. Okay. That is the initial force is F. Frictional force is one thing, initial force, this and this. The total four forces are acting. Now see the initial force is in the negative because it has to apply in the reverse direction. The T is also negative. The T is also the negative value. And F is a positive. That F we can put the positive and find out the unknown value. Similarly, the second block. The second block is, this is in the initial force applied in the opposite direction. And this is the frictional force. This is the torque tension. By using the same concept, T minus Fi is equal to M. And substitute the values and simplify the problem. Okay. Now let us consider the generalized equation. How we will represent it in a rectilinear motion. In a rectilinear motion, I already mentioned, let us consider translation. In the translation, we have only 1 degree separate. That is the translation in x direction. Sigma mx dot is equal to mass into acceleration. That can be written as here x plus initial force is equal to 0. This initial force is this time. And mass is the mass of a body. Now the above equilibrium may be a dynamic equilibrium. Okay. If you consider the total mass of the system here, the force is equal to the mass of a particle here, mass into acceleration. That is the initial force. Mass into acceleration. It is always a negative quantity. Why? Because we will apply in the opposite direction. Okay. See now, this one, what we are calling as initial. This is equal to F I, initial force. you find out the unknown value and see that all conditions Fy is equal to Fy into initial force. Now let us consider pulley, weight W1 and W2 acting with the two masses, fixed pulley, two masses, mass M1 and mass M2, weights acting downwards, W1 and W2. The equilibrium equation is weights and here the body, which is in the body here, now if you can consider weight acting downwards, W1 and W2, tension acting upward, there is no mass, that's why there is no, even the body is in rotation, but we are not considering any mass here, mass momentum. Compared with these weights, the mass is negligible. Only we are providing, this is the rotation converted into translation. Then weights are acting downwards. The equilibrium equation can be represented as, assume upward, let us consider the equilibrium equation by the entire system. This is M1 X1 double dot. I am taking downwards and it is upwards because this is the rotation. To keep an equilibrium, you have to apply in the opposite direction. When you are applying in opposite direction, this has to move in this direction. Okay, this is the initial force upward, this is the initial force downwards. M1x and M2x. Now, M2 x double dot. Now the system is in equilibrium. Some other force equal to 0. This is now what we have to do. This is one force. This is the second force. This is the third. Three are in the same direction, positive. So that's why if you can make only the concentrations, M2 x dot plus W2 plus W1 minus this also applied upwards and the three are downwards. Okay, then you can consider the problem is M1 if you move x2 double dot to left hand side and simplify the problem, we'll keep this is what is the dynamic equilibrium conditions. Okay. Now this can be further simplified by a small problem, W2 g dot. As tension is acting outwards, acceleration is towards down. The body is said to be dynamic equilibrium, considering the real and imaginary force. That is what S minus W by G, because this is upwards and these two downwards. This is positive and this is negative. Okay. Because W1 is moving upwards, W2 is downwards after applying initial force, not before initial force. So this is what is the expression we can use and find out the tension in the string. So that can be determined, the tension in the string and any unknowns can be, this is the acceleration and the tension can be determined by using this like this. Okay, this is how we will apply the D'Alembert's principle for any type of system, whether only with two masses or it is. But here important point is we are not considering rotation, we are considering translations. This is one important point you have to keep in mind. We are not considering the rotational part. Now let us consider. Note down the problem. Find tension S. Find tension S in the string during motion of the system. During motion of the system, if W1 is equal to 900 newtons, W1 is equal to 900 newtons, W2 is equal to 450 newtons. W2 is equal to 450 newtons. Mu is the coefficient of friction between the inclined plane and block. Mu is the coefficient of friction between the plane and block. 0.2. 0.2. Find out the already given. You have to find the tension in the string during the motion. Okay, two weights are given. Input data is two weights are given. Friction between the plane and block 1 is given. The frictional coefficient is given. Okay. So now what we have to do is draw a free body diagram of this block. Normal reaction upwards, weight acting downwards. When it is moving up or down, that we have to decide. Okay. Now here what we have done is this weight compared with weight W, W1 is higher, 900. All the forces, assume as a static, there is no dynamic, then it is moving. Half of them. Mu when one moves downwards in the inclined plane with an acceleration A, this problem already we have done. This is x1, this is 2x1. You differentiate x1 dot to x1 dot, x2 dot to x2 dot. Then x2 dot is equal to x1 dot by A. This is what is your x2 dot. Obviously A by 2. W2. W1 is A. And this is how we will consider the accelerations. Now you can see the component W1 cos 45, W1 sin 45. This is W1 sin 45. When it is moving downwards, inertia force is acting in this direction. Tension in the cable is tension and inertia force in this direction. W1 cos 45 is in this direction. Is equal to plus the inertia force at 0. That means F S plus S. S is 1, W1 sin alpha 45 and frictional force to mass into acceleration, inertia force. Okay. See, these two are in the same direction, S and mu n. Frictional force is also acting in this direction. See, that's why W1 mu times normal reaction and minus S both are negative. W1 cos 45 in this direction, that's why it is positive, minus mass into acceleration, W1 into E, that is the inertia force. Because inertia force, frictional force, tension in the string are acting in the same direction. W1 sin 45 acting in the opposite direction. That's why this is a positive sign and these three are negative signs. Because inertia force is also should act in this direction. Inertia force we have to consider. Action plus weight cos 45 plus inertia force. Now this equation can be further simplified. This equation can be further simplified. This equation, F, mass into acceleration, W sin 45, mu times normal reaction, yes. From this, W1 is known to you, and normal reaction is, you have to find out from this vertical, W1 cos 45 is equal to N. From that N you can find, substitute this one, mu times W1 cos 40. Now the acceleration is an unknown, you find out. Okay. Now let us come to this free body diagram. This part of free body diagram. This part. Here see, when it is moving downwards, inertia force is acting in this direction. Here also inertia force is acting in this direction. So that's why two forces, weight downwards, inertia force is acting towards down. Okay. 2s minus W and the inertia force. So that's what? 2s minus W and minus. This is also acting in the opposite inertia. But only the earlier acceleration is A, it is Ay. Okay. From this, find out the tension in the string. Yes. In terms of A. Once we know the A, you find the unknowns. Okay. So like this, we can solve the same problem can be done on Newton's law. In that case, this is equal to this. That's all. Mathematically speaking. That is W1, here you put equal to and this is positive. That is a Newton's second. But sometimes to convert a dynamic problem to static problem, depending upon the situation, you can use this particular concept. Now let us note down another problem, similar problem. Two weights P and Q. Please note down, represent, you practice, then you will get, you clarify all doubts. Two weights P and Q are connected by the arrangement as shown in the figure. Two weights P and Q are connected by the arrangement as shown in figure. Neglecting the friction and inertia of pulley inertia of moving pulley and fixed pulley. Neglecting friction and inertia of pulley and find the acceleration A of weight Q. Assume P load is 178 newtons, Q load is 133.5 newtons. So now let us see here. This is the acceleration. This is the acceleration direction. This is the acceleration, opposite to that we are applying inertia force. That is Q by G into A. Q by G, that is Q is a given, that is the weight of this mass into acceleration A. The tension in the cable is A. That's where Q downwards, weight is acting downwards. So now it is a dynamic equilibrium. Once you applied a inertia force in the opposite direction, it is dynamic equilibrium. Dynamic equilibrium, some of the upward forces, downward forces. Anything can be positive, upward positive, downward negative, or downward positive, upward negative. So now if you can see, this is what is the weight of Q minus S minus Q by G. See, this is what is the equation. Okay. From this you can determine S is equal to A into 1 minus A by G. Okay. And we can determine, and all values are given. A 133.5, 1 minus A by G. Similarly, apply D'Alembert's principle. Here you can see I already mentioned number of times. Here, if accelerate because points. Okay, x1 is equal to x1. You can consider the displacement of weight q. X2 is the displacement of weight p. One is upward and it is downwards. If it is x1, it is 2x1. 2x2 plus x1 is like that. If you can consider differentiate, we'll get a by 2. Now, let us consider simplify this problem. You cut it here. Free body diagram. This is the initial force. P and this acting in the same direction, and 2s is opposite direction. If this is positive, this is 2 negative. 2s plus p minus p by g a by 2. Okay. From this you find out s. There are two equations, two unknowns. This equation is one equation. This one. And this is the other equation. Now from this two unknowns you can solve two problems. So similar problem here, two blocks. Note down this you can do as an assignment. Two blocks, W1 and W2. W1 and W2. 150 newtons, 500 newtons are connected by inextensible string with a fixed pulley by making an inclined plane and plane surface. Inclined plane angle is 45 degrees. Find the acceleration of the blocks and the tension in the string. The block 1 friction between the two surfaces 0.1 and block 2 is 0.2. Block 2 is 0.2. Note down the sketch. And please try the assignment. If you have any problem, we will discuss. Similar problem, see this is where we have done. So now let us see the same thing, similar application. Where mu is 890, that is W1 is 890 newtons, W2 is 445 newtons. Mu is 0.2 and alpha is 45. But here acceleration is given downwards. When acceleration is downwards, it is moving upwards. That is the actual motion. But you have to apply initial force in the opposite direction. Like this. You have to apply initial force in the opposite direction. Not at all. So now what we have to do is W1 sin 45. This W1 Sine, this is a 45 degrees alpha. W1 sine 45 is opposite direction. Inertia force is in this direction. This and this positive. Frictional force is this one opposite. That's why these two are in the same direction. And frictional force is also inertia force also. That is F5S and frictional force. These two are same sign. Can be positive, it can be negative. W7 sine 45 is opposite this direction. Okay. This is how we will write the equation. S is equal to W1 sine 45 mu n in minus W1 by G into A. See, this is how the tension in the string can be obtained. Then weight of the here. If this is A, acceleration in this direction. Here it is A by 2. Now see, this is the inertia force direction. And these two are in same direction. That's why 2s plus F minus W by G into A. Minus W by G. A is acceleration. This is the equation. And solve the two equations. Two s minus W2 F2 upwards F5. This one. 3 forces. Depend upon the upward, downward, you put a positive sign, then solve the problem. Similarly, but only the little bit change in the values. Now let us note down the other problem. And 2 blocks resting on inclined plane, one touching over the other. Note down the block weights are, note down the problem, the block weights are WA is equal to 44.5 newtons. WB is equal to 89 newtons. WA is equal to 44.5 newtons. WB is 89 newtons. Alpha is equal to 30 degrees. Alpha is equal to 30 degrees. And mu is equal to 0.15. Mu is equal to 0.15. 0.2 mu A. Mu B is 0.3. That is the given data. Find the pressure P between the blocks. That is the reaction between the blocks. Find the pressure P between the blocks. Okay. Now if you can see the free body diagram here, this is the reaction force, this is the tangential force, this is WA resolve in this direction, this is WA sin alpha, WA cos alpha. As far as inclined is concerned, this is the frictional force. Because the block B weight is 89 newtons, block A is 44. And here the friction is 0.3, more in friction is 0.15. Without friction, if you can consider, this block tends to move in the downwards. Okay. With friction also, if you can consider, it is 22.5 and it is 0.30. Even then also it is more than that. That's why the block tends to move in the downward. Now we have the inertia force apply in the opposite direction. W sine 30, W sine 30 in this direction, P opposite minus P, and mu times R, that is the frictional force, is equal to inertia force. The inertia force, this is the force in between the two blocks. The inertia force is also acting the same. Only this component W sine part in this direction, P is acting in this, frictional force is acting in this, inertia force is also acting in this. Those three are one signature, and A sin alpha is the other signature. W sin alpha positive, right side, and all the left sides are negative. From this, substitute the data. WA is given, all mu coefficients are given. Similarly, draw the free body diagram for block B also. See, this is what block A is. The two equal and opposite forces are acting at this point. Now apply force in opposite direction. Again, frictional force in the same direction. If here the frictional force like this, moving upward, it is acting in the opposite direction. B, this is what the condition. Now again resolve. Here if you can see, P acting opposite, mu frictional force, P and W sin 45 or cos 45. Sin 45 in this, cos 45 in this direction, sin 45 in this direction. Okay. Now P and W sin 45 in the same direction, mu inertia force is in this direction, these two are in one direction. See, these two are one thing and PWB same. From this find out the P value. See, this is how the problem, any type of problem can be solved. Either Newton's law or D'Alembert, both are force equations only, no difference. But only thing is, one problem we are solving Newton's law, we are solving by considering the dynamic condition. D'Alembert's principle we are applying, this is the D'Alembert's, we are converting a dynamic problem into static problem. That equilibrium we are calling it the dynamic equilibrium. And unknowns can be determined. Now in the rotation, the curvilinear translation motion, how to consider the acceleration during a motion. This yesterday we already discussed. If you can consider tangential velocity v, the dv is equal to dv by, if it is a small angle dv d theta, this velocity is dv and d theta. And then you can represent the equation dv is equal to v d theta. dv by d theta is equal to v. Okay. From this d theta you can substitute as ds by r. This is dv and this is d theta, this is v. See, that's why this dv is equal to v d theta. That's what we have written here. Both are different. These are velocity diagram, velocity point, and this is displacement. ds is equal to v phi or v d theta. Now that is the second relation. The acceleration dv by dt is, that is acceleration, is equal to v square by r. Okay. You can find out and try to simplify the problem if you can differentiate with respect to time. Then once we know the normal acceleration, the initial force is mass into acceleration. That is W by G into V square by R. So now we can apply curvilinear x and y are the normal and tangential. X and y are x is equal to mx double dot, my double dot. Or here x plus or initial force in the normal direction we can count plus tangential direction is equal to 0. Okay. These are the two equations. R, Y. R tangential direction and normal direction. You can resolve the forces. Let us consider the racing car traveling around a circular track of 300 meters radius with speed of 884 kilometers per hour. This yesterday we have done angle of banking. What is the angle floor of the block make with an horizontal in order to safeguard against skidding? See that expression we represented yesterday, tan theta is equal to v square by tan alpha, or theta is equal to v square by rg. V is given, R is given, and G is 9.81. See, substitute that, we got 75.5 degrees. Okay. So this is what the simple curvilinear motion. Simple curvilinear motion. Yesterday we have given the equation, but now we will see. Let us consider this is the problem. Okay. Find the proper elevation E of for a 7.2 meter highway curve of radius R is equal to 600 meters. In order to car traveling with the speed of 80 kilometers per hour will have no tendency to skid. So this is what R is equal to W by G into V square by R. And tan theta is equal to V square by Rg. That can be obtained. W sin alpha in this direction is equal to mr omega square, or mv square by r into cos alpha. That component, if you can find out, you will get. Resolve the forces along axis. From the geometry, the super elevation height is E. This tan alpha, if you can consider E by P sin alpha, this is for a small angles, sin alpha is equal to tan alpha. This one. Now equate the two expressions. Find out E is equal to V square by R. And you can find out the now let us see the one curvilinear motion is projectile. This is also very important concept in curvilinear motion. This can be solved by using Newton's second law or by using D'Alembert's principle, or even if you can solve work energy or a moment impulse. Projectile motion, when you throw a ball, it come down. It can be a vertical motion, freely falling object, force due to gravity, vertical component velocity with time. If it is horizontal only, motion of a ball rolling freely along the level surface, horizontal velocity is always constant, or a parabolic, path traced by an object, accelerating only in vertical direction while moving at constant horizontal velocity. Okay. So this is how we will consider the problem, horizontal, vertical and parabolic nature. Now the projectile is, we have at each and every point of time we have ux, uy, the tangential velocity, again u, but here theta is some value and here it is 90. When you are coming here, ux and uy at the topmost point, maximum height is reached. The velocity in the displacement in that particular direction, 0 y direction, because it has to come down. Then ux is equal to, so like this, uy is 0, and this is ux and uy. Now let us see, these are the, when a person hitting the ball, how the path, it is again a best example of projectile with different angle of inclinations. Theta is equal to 45, 30, 60 like that. And this is the maximum height, this is the maximum range. To reach this range, what is the time of flight? These are the three parameters generally will determine maximum height, horizontal and vertical, delta x and delta y. Now let us see, you can throw a ball from a particular height of the building. Now how it is fall? Or after hitting the reference surface, it is going down. Similarly like this is the reference surface what I mentioned. If you are in a second floor, this is the reference. Now throw it, it will come to the first floor, ground floor also. See, this is the case when different angle of incidence, that is 45 degrees, 30 degrees, 60 degrees, etc. This is the angle of inclination is same, but different velocities. 2, 4, 6, 8, 10. See, like this we can come across different cases of a projectile motion. Now let us see, this is when the body in a x translation, v is equal to u minus gt. Why? Because here acceleration due to gravity is always downward direction, minus g. Okay, v minus v is equal to u minus gt, s is equal to ut minus half gt square, v square is equal to u square minus 2gs. Okay, where x is equal to vx into t, y is equal to, at the peakmost point, ut plus half gt square. G is downwards. Then the vertical velocity, horizontal velocity. The displacement you have to differentiate with respect to time, you will get the accelerations. So now here, x is equal to u cos theta and y is equal to u sin theta minus half gt square. Why? Because y direction we have acceleration due to gravity. In x direction there is no acceleration. S is equal to velocity with time. Displacement is equal to, here y is equal to displacement time plus gravity effect. Like s is equal to ut plus half gt square. Yeah, x direction also x is equal to ut plus half gt square. But here there is no g in x direction. That's why it is 0. You solve these two equations, we will get the unknown value. X is equal to ut cos theta, y is equal to ut sin theta minus half gt square. If you can solve, we will get this is the second order equation C. Y is equal to x plus x square. That is what is called the parabola. See, that's why it is a projectile is always in a parabolic nature. Projectile motion. So these are other when a bullet is firing or a ball is freely falling from the height of the building. Here, these velocity equation again same as previously what I have given. And here range is equal to u cos theta into t. That is the linear velocity. Time of flight to t is equal to, you can substitute. This is what is the velocity v and the x direction. Displacement x is equal to vt, y is equal to vta. These equations can be obtained. Now let us consider the dynamics. In horizontal, there is no acceleration, vertical only, because of gravity only the projectile motion is taking place. So that's why only the vertical reaction, no horizontal, zero, no force. Force is acting only weight, that is downwards, no force in horizontal direction. M into x double dot is the dynamic equation 0. My double dot initial force plus, or you can write in D'Alembert. Both are same. If we can resolve this, u cos theta and v sin theta, resolve the component and determine the unknowns. Now, maximum height and time of flight can be determined. See, this is what is the, again range of projectile. The horizontal speed into time, that is horizontal is u cos theta, vertical is u sin theta, because it downwards, it is horizontal positive, vertical upward is positive, but here downward u sin theta, acceleration due to gravity upward, but gravity downwards it is negative. See, then time of flight is equal to v minus u. V is u sin theta minus u sin theta is equal to minus g, you will get 2u sin theta. That is what the time of flight. Then range is in a constant, here in this particular case he is using an expression u cos theta into t. This will take care by, the range is equal to u cos theta into t. That is the range we can, t is already we got, give cos theta, if you can say 2u square cos theta sin theta, u square by j theta or sin 2 theta. Now let us see, the same expressions are given here. xy parabolic equation in xy direction, x direction vt, and this is the parabolic, time of flight, range and height. Now see the horizontal motion, vertical motion, linear velocity in x direction, where acceleration is 0, acceleration is g, v is equal to u cos theta, vy is equal to u sin theta minus g, like v is equal to u plus 80, plus but here minus, why? Because here negative sign is there. Okay, then the maximum height, time of flight, range, other expressions can be determined by using the different conditions. Now let us consider the rotation, D'Alembert's principle in rotation. For a rigid body in a plane motion and rotation, because it is a combination of translation and rotation. This is the translation equation, because the system of force are acting. In this is equal to mass into acceleration. This one. Moment is equal to, instead of mass moment of inertia. Instead of linear acceleration, angular acceleration. If it is 0, only rotation, the equation 1 is valid. If it is this is 0, only this, the translation is positive. Okay, so that's why you have to find out the MEX. These are if it is a vector, 2 equations, x direction and y direction. This is only one rotation. So that's why the 2 vector equations become 3 dependent scalar equation. Independent, 3 independent scalar equation, not dependent. That is Fx is equal to max, Fy is equal to may, moment is equal to igr. Like torsion pendulum, where only rotation. These problems can be solved by using this type of D'Alembert's principle. See, this is what is the torque. Torque, the resultant force, where you have to consider that you can simplify. That is one schematic representation. See, this is where this body is in rotation, this is in translation. That is the philosophy where the body in a translation and rotation. If it is given I, if I is not 0, there is no acceleration of this. We don't consider the I alpha, that is rotation. Only will consider translation. M is a MA, can be considered. Now, before D'Alembert's principle, see the resultant force. This is the resultant force, multiply with center perpendicular. Now, by applying D'Alembert's principle, this torque you have to apply in the opposite direction. Instead of this, now R minus MA and MT minus IF. Translation equation and rotation. Because this body is in a plane motion. If a rectilinear translation and rotation, only one translation, one rotation equation. If it is a curvilinear and rotation, X equation, Y equation and rotation equation. See, that is what this is the case. In a plane motion, Fx is equal to max, Fy is equal to may, moment is equal to I out. We will consider. See, this is how generally we will consider the three cases. Fx is equal to mass into acceleration, Fy is equal to mass into acceleration in y direction, moment about IL. The external D'Alembert principle says that the external force acting on a rigid body are equivalent to the effective force of various particles forming on the body. So this is how generally we will consider the plane motion of a rigid body. Now consider a small example. Note down, two balls, this is the rotation problem. Two balls of weight, please note down, this is one important problem. Two balls WA and WB, weights 44.5 Newton and 66.75 Newton. .5 Newton and 66.75 Newton are connected by an elastic string. And supported on a table as shown in figure. When the turns table from rest, the tension in the string is 222.5 newtons and the balls exert the same force. Balls exert this same force on each of the stops A and B. What forces will they rest on the stops? There is a reactive force between the stops and the ball, spherical ball. When the turntable is rotating uniformly, about the vertical axis, CD at 60 rpm, revolution per minute, and the radius of two balls from the center of the rotational axis is 250 mm. This is the given data. In the schematic representation is given, weights are given, WA is given, WB is given, that is 44.5 newtons, 66.75 newtons. S is equal to the tension between in the string is 222.5 newtons. The normal reaction, normal speed, that is the speed is given, disk speed 60 rpm. See, and radius of the two balls is same, that is 250 mm. And omega is equal to 2n by 60. Find out the speed omega, angular velocity. Now see the Peabody diagram. Because it is a centrifugal force, so there is a normal acceleration and tension in the string. Because it is away from the axis, normal acceleration, reaction between the stopper and the block. The stopper acceleration is when it is moving ball outside, the stopper is between that there is a reaction. Here also RB and normal the inertia force. And this is the tension in the cable. Okay. The block one consists of these two in one direction, this is opposite, that's why this plus this is equal to this MR omegas. One case. From this find out R naught. And the second one, this is the direction, RB is this, S. Now if you can consider the second RB plus this one minus S, R equal to S, R2, this is the downward direction. Wait, that is what is the second equation, find out the RB. See, once we know the two equations, find out the case. See, this is how the equation. Now let us go to the now let us see the equations for when the body in a general equilibrium equation. See, if it is a body in only x direction, translation fx max, fy 0, fz 0, translation. If all three are there, then these are the equations. In dynamics, max, may, maz. If only x translation is concerned, then neglect y and z. This is how generally will consider. Then if it is a static condition, this is also 0. These are only dynamic equation. This is a linear rectilinear motion. In a curvilinear motion, two-dimensional, this is 0. Only fx and fy. But here the combination is you can consider translation along x and y or normal and tangential. You have two choices. In a vector notation, the acceleration force can be represented because force and acceleration are proportional. So this can be determined, the resultant force is equal to square root of x square plus y square z square. Here x is fx. Summation of the force in x direction, sum of the force in y direction and sum of the force in z direction. See, you have to find out these are three forces: weight, tension, the P is what is the, now find out the, here also small problem where this rope is moving along that, this is the tension. There is rope is connected and the weight is acting. The three forces, rope is moving along the rope. This kinetics of a particle, same thing, resolve the forces along x direction 0. These are the equations. Fx is equal to max, Fy is equal to may. Ax nothing but x double dot, ay nothing but y double dot. If it is a normal and tangential, ma normal, ma tangential. Normal acceleration is v square by r. Tangential acceleration is, this is the normal acceleration, tangential acceleration is this. Okay. Polar coordinates is radial and angular direction. This is again example of curvilinear. This is explained already. Like this, the vehicle can travel in a curvilinear motion. This is again the body in a rotation, if you can see. This is the rotation about one axis, this is the rotation about other axis. This type of problems also curvilinear path. You resolve already polar coordinates. Now this is the work and energy, moment impulse. The two more concepts which we are going to discuss in the tomorrow class. Today we mainly concentrated on, if you can recollect, by using D'Alembert's principle, we can convert dynamic problem into a static problem. That equilibrium we are calling as the dynamic equilibrium. How to apply this equation to dynamic problems like different motions, that is rectilinear, curvilinear, rotation and plane motion. Plane motion we have not discussed much, but what is the concept is explained, because once we completed work energy, moment impulse, etc., we will discuss what is the plane motion in detail. But kinematics part little bit we discussed in the plane motion. Then by applying D'Alembert's principle, if it is a translation, how to apply these things for rectilinear translation problems and curvilinear translation. Like a body moving in inclined plane or a plane surface, these are all rectilinear problems. In curvilinear problem, when the body is moving on a path like a projectile or a curved path. Here at this particular juncture, what we have to do is, we have to resolve the components in x and y direction, or do you resolve the components in the normal and tangential direction. The choice is yours. Depend upon the convenience, depend upon the data given in the problem, we have to find out whether we have to resolve the force in x and y, or do you have to resolve the force in the normal and tangential direction. Okay, using work energy momentum principle. Then tomorrow we will concentrate the work energy momentum impulse principles, how these problems can be solved in place of the previous ones. Instead of Newton's second law and D'Alembert's principle, both are force equations. But momentum impulse work energy is not a force equation. Depend upon the data given in the problem, which principle has to apply. We have. So this is how generally we'll try to solve the problems in case of dynamics. We have done kinematics, we have done kinetics. Kinematics, we have done space-time relationships. For translation, rotation, in translation, rectilinear, curvilinear and plane motion. We have done relative velocity method. Only we have not done instantaneous center method. That is the plane motion case. Okay. So now with this, I hope you understand the today class. Starting a small problem with a net. See now, with this we will stop today class, and tomorrow we will again start with the two new concepts, that is work energy, momentum impulse, because Newton's law is also defined as rate of firing a bullet from the gun. These all we will consider the problems. Okay. Sometimes the energy stored, work or kinetic energy, potential energy or strain energy, spring energy. How these problems can be represented? Here the basic idea is work energy. The work is represented in terms of displacement. Momentum impulse is represented in terms of the velocities and time. In addition to force and mass, anyway it will be there. Okay. So these two concepts, how to analyze things in dynamic case, we will try. Okay. So with this, I will stop today class. If you have any queries, please pass on through Google Form. Google Forms represent velocities in addition to the mass. Thank you very much for patience hearing. Tomorrow again we'll meet at 10:30. And best of luck for the entire day. Thank you very much. Have a nice day.